Hi children, welcome to the online revision session today. We will be focusing basically on limits and differentiation. Just want to share with you that across limits, remember we started with the existence of limits followed by evaluation of limit sum. There are different types in that: substitution, factorization, rationalization, and of course the standard forms also do exist. Following that, we went into differentiation, that is derivative of a specific function. Now in that, the main focus was to find the derivative by first principle method. Just to share with you, in class 11, finding the derivative of a function by first principle method will always be a favorite, because the other part, that is find the derivative by using the formulas, is extensively done and used in class 12 syllabus. But of course, you have to focus on both in class 11, but class 11 for formula method, it will be at some primary level questions. Having said that, without wasting time children, so let us begin with this wonderful session on limits and derivatives. And I promise you, your time spending on this lecture today will be surely worth 100 times more than you feel right about it. So let us begin with this first question on limits and differentiation. Okay guys, here we go. If we have a look at this particular question, this question is something very different based on the first exercise of your limits topic. That thing, find whether, not fx exists, find whether the limit of the function exists. Find whether the limit, okay, find whether limit of the function exists as x tends to 0. Find whether limit exists, not function exists. So I'll just make it simpler now for you. Okay, just a second. So I'll explain to you exactly what it is. Find whether limit exists. That is, the limit of the function exists. Great. Now before we proceed, I want to share with you, when does limit of a function exist? Limit of a function exists if and only if left hand limit is equal to right hand limit. Remember this, limit exists if left hand limit is equal to right hand limit. Now what is left hand limit? Okay, left hand limit at x equals to a. Okay, so this is limit of fx as x tends to a bar is equal to limit of fx as x tends to a plus. So as I said, right of a and left of a, if these two values becomes equal, I can say limit of a function exists at this particular point x equals to a. Now they are asking us, find whether the limit of this function, this is a single function actually, but this is given in pieces. Limit of this function exists at x equals to 0. That's what exactly we are looking at. Okay. Now let me talk about the existence of limit. So as I said, limit will exist only when this value is equal to this value. So let us have a focus or a look at whether we can prove the left hand limit is equal to right hand limit. So here we go. The first part starts for left hand limit. Okay, left hand limit and right hand limit will work out as we go on. So guys, let us start. First thing is, you know that left hand limit is nothing but limit of a function as x approaches. Now here it is 0, so 0 bar. Now left of 0. So first of all, you have to see, you cannot write function, you have to see which function is valid. But here there is a problem because this is x upon modulus x. So what I'm going to do is, I can, write this function as fx, pay attention now, it is x upon, x upon x actually, you can say positive x, when x is less than 0, x upon negative x when x is greater than 0, and it is x is equal to 0, the value is 0. Because this x can be positive or x can be negative. This was the definition of the modulus what we studied in class 11 when we are dealing with trigonometric functions. Okay, so having done that, so let us see what happens now, guys. Okay, now you can cancel this here itself. Okay, so suppose you don't realize this, that you have to do this. So what I can do best is, for the time being, you can ignore this if this you don't get it. If you get this, it's very, very easy to work out. But suppose you don't remember this particular working on modulus. So how I do it? So let us talk about the function. The function x tends to 0 bar. So you have to say which function is valid, either first one or the second one. This function 0 is valid when x is equal to 0, but this is x is 0 bar, that is from left of 0, right? 0 less than 0, that means this first function x is not equal to 0 means this function you can take up. So this will become, I am just writing it out here, guys, is equal to limit of, you can say x upon modulus x as x tends to 0 bar. Now remember, my objective is to find the value of the left hand limit and the right hand limit, and if they both are equal, then I say limit exists. So if I am going with left hand limit. Now I wrote the function what is valid, but remember one thing, 0 bar or 0 plus, I mean to say a bar, a plus is a non-usable value, because when I say 0 bar, that is left of 0. Left of 0 can be any value. So you have to be very specific. So what is my working here is, whenever I am finding the values, so what I will do, let x be equals to, now I have to take a specific value less than 0. So I will take, let x be 0 minus h. Understand, this procedure has to be done for all the sums on existence of limits. So please understand that. 0 minus h. That means x is replaced by 0 minus h in the question. So what happens now quickly? So let us say limit of, this will become 0 minus h upon, this will become 0 minus h. Now remember, x is tending to 0. So if x becomes 0, h will automatically become 0. Because once h comes in the picture, this has to be h only. Keep that in mind. Okay, so now I write this out for your consideration here. So it will be limit of minus h upon, this will be modulus of minus h as h approaches 0. Now having done this, now this is a usable value. Remember, a bar, a plus is a non-usable value. So I convert this to usable by using a substitution technique. So once you finish with this, my working starts. So I think it's a very simple working. So limit of, I can say minus h upon. Now try to understand, now modulus of any negative number will be positive. So I can write here positive h as h approaches 0. So this cancels. So this is nothing but minus 1. Because limit of a constant will become minus 1. So in short, my left hand limit is minus 1. Similarly, let us come to right hand limit. Now what happens with the right hand limit? So right hand limit, where is the right hand limit? This is my right hand limit. So this will become limit of fx as x tends to 0 plus, matlab from the right of 0. Which function you have to take? Right of 0. Look here, this function is for x is equal to 0 and this is x is not equal to 0. 0 plus matlab greater than 0. So greater than 0, less than 0, the same function I am going to use here. So this will be limit of x upon modulus x, please pay attention, as x tends to 0 plus. Now as I said, a bar and a plus are a non-usable format in limits. So they are not, because a bar means less than a, which value I don't know. Very near to a from the right hand side, very near to a from the left hand side. So what I am going to do, I am going to use the same technique of substitution. Now you might ask me, sir, what I will substitute? Now understand, I am taking a value less than 0, that's why from 0 I reduced h. Here I am taking a value greater than 0, so I will take a value 0 plus h. So let x be equal to 0 plus h. So what happens quickly, let us see. So this will be limit of 0 plus h upon modulus of 0 plus h. Please understand what is happening. Okay, I repeat my word, 0 plus h as h approaches 0. Because once h comes in the function, you have to use this thing. So immediately this will become limit of h upon modulus h as h approaches 0. Positive h is 1 only. So h upon h will become 1. So if you see carefully, understand what happened to left hand limit. Left hand limit is nothing but minus 1. And what is my right hand limit? Can anybody tell me what is my right hand limit value? You can see on the screen. Come on, I want you to be interactive. What is the value?
1.
1. Absolutely right. So my left hand limit is minus 1, right hand limit is 1. Therefore, I can conclude left hand limit is not equal to right hand limit. So guys, if left hand limit is not equal to right hand limit, what you say, what you conclude? Therefore, limit does not exist. Limit does not exist. I hope this clarity on this procedure is there while explanation. Okay, please make a note of this question quickly. Now finish it off. I give you 3 minutes to copy down this question. Hurry up fast. Quickly. See, I can share the notes, but I know sharing the notes, in the end, just sharing the notes, it doesn't give you any support or any help. The more you do right, I think that is, more useful for you. Keep that in mind, okay? So please make a note of it quickly. The first question of a revision, Elijah and all those people, please be on time. It's really difficult for me to cope up later on for those who missed with specific questions, okay? So please take it down quickly. We are doing limits. We are doing a revision of 03 limits and differentiation. Okay, so here we go. The first question is on display. Your time starts now.
Yes, sir.
Let's take the next question. I'll share the notes, whatever, okay? Second case says find the derivative. F dash x ka matlab is dy by dx. Keep that in mind, okay? Find the derivative by definition. Remember, by definition, first principle, ab initio. It means, you know the standard formula, right? So based on that. So by the way, first step, you can do many way this particular question. So what is my suggestion is, you can go ahead with x square minus 1 upon x is much better, just to simplify this function, and then I will share with you what is the procedure. Okay, now this is my function. Okay, I just made it look simpler, that's all. Otherwise you can keep this as it is and do it. Jo jeeta wo sikandar iske andar. Okay guys, so let us see what happens now. Now they are asking find the derivative of this function, I mean to say this function, by definition. So by definition, everybody knows dy by dx is limit of f of x plus h minus fx divided by h as h approaches 0. So basically in derivative, the first principle is also a limit sum only, because you can see the limit has come into picture. So if you know limit very nicely how to work out, I think finding the derivative by first principle is much easier to ponder upon. So let us see what happens quickly. So as I said, to find dy by dx, I need f of x plus h and fx. So what is given to you here? F of x plus h. Now f of x is given to you, I note it down. F of x is x square minus 1 upon x, and f of x plus h also I need to substitute in this formula. So f of x plus h, now understand, f of x is already given to you. So I know f of x plus h, this x is replaced by x plus h. So in the sum also, as x is replaced by x plus h, the sum also x is replaced by x plus h. So x square, I can write x plus h whole square minus 1, this minus 1 as it is, upon x plus h. So once you get this value and this value, f of x plus h and f of x, take this and put it in the formula. So what happens now? Let us see. So dy by dx is limit of f of x plus h, make a note, x plus h whole square minus 1 upon x plus h minus f of x. F of x is already given to you here. This is nothing but x square minus 1 upon x full upon h as h approaches 0. So basically, if you look at this pattern of appearance here, this is solving a limit question. But what happens in the numerator, you see there are many fractions. So best way is find the LCM and simplify. Let us see what comes out of it. So I am just taking it over here. Dy by dx is equal to limit of h approaches 0. May I have a note? I am finding the working of this. So before that, you can simplify here itself. I will tell you what I propose to do. So you can just simplify this. So dy by dx will be equal to limit of h approaches 0. I mean to say, I am opening the bracket here. It becomes easier for me. So this will become x square plus 2xh plus h square minus 1 upon x plus h. I did applied a plus b whole square minus of x square minus 1 upon x upon h. This h I took it over here. Okay, so let me solve the numerator by finding the LCM. So limit of what happens now, this is upon h as h approaches 0. Now if you see the denominator here, what is the LCM? X plus h into x, right? And then cross multiply x into x square. Now x into, I am just doing the LCM now. X into x square is x cube, then 2x square h square into x is plus h square x minus x, and come here, there is a minus sign here, be careful. So minus x square into x is minus x cube, then minus of minus is plus 1, 1 into x will become x, then h into minus x square, so minus hx square. I hope I am right. Please understand this, what is happening here. Hx square and minus into minus is plus h. So I just simplified this. You can do the way you feel comfortable doing that. I just worked out. Now let us see what I can really get it out. X cube gets cancelled. Then anything else gets cancelled here. Minus x plus x gets cancelled. That's it. So let me just write down dy by dx is equal to limit of h approaches 0. Now let us see what happens. This denominator x plus h into x, and this h of the denominator will come down along with denominator. I mean to say the denominator of the numerator will come and join the denominator. And see what is left out here. 2x square h. So if I take 2x square h plus h square x, then minus hx square plus h. That's it, I think, and nothing is left out over here. Okay, fine. Now once you finish with this part, I think I can take h common from the numerator. Dy by dx is equal to limit of h approaches 0. Just see what happens. This will be remaining as it is. X plus h, x and h. H if you take common, what will remain? 2x square plus hx minus x square, okay, plus 1. Oh, plus 1. Hx square plus h, I took 1 common, okay. Might be right, whatever. So immediately what is going to happen now? This h will get cancelled here. So immediately when I look at the denominator, if I take h is tending to 0, it doesn't become 0. So when the denominator doesn't become 0, you can take the limits. So taking limits, that means I have to put h tends to 0. So what happens? Dy by dx. So 2x square, there is nothing to put. 0 minus x square, there is nothing to put here because h is approaching 0 and not x. Make a note. Here also there is nothing. Upon this x plus 0 is x. X into x will become x square. Okay. I am done with this now. There is some sort of working problem. No, I think it's right. So let us see now. So what will happen? Dy by dx, it will be 2x square minus x square is x square plus 1 upon x square. Great. So this is nothing but 1 minus 1 upon x square. 1 plus 1 upon x square. So that's the derivative there. Okay, that's the derivative. So I think I can do it. You know why? This is absolutely right answer. I'll tell you why. Now look at this particular part. Dy fx, what is the derivative of x? 1 minus, as it is, 1 upon x. If you remember formula, what is, anybody can tell me what is the derivative of 1 upon x by formula method? Do you remember? You can use the power rule and do it, or directly I can say 1 upon x derivative is minus 1 by x square by formula method. So the 1 upon x is nothing but minus 1 by x square. So this is nothing but 1 plus 1 upon x square. So this is the formula method of dealing with it. So 1 plus 1 upon x square, 1 plus 1 upon x square. This method is the first principle method. This is directly I use the formulas and finding the derivative of the function. This is just to confirm whether my answer is really to my teacher's expectation. Okay, I mean to say mathematical expectation, sorry. Okay, so I hope the procedure you understood, f of x plus h fx, and then put in the formula which I had given you here. Once the formulas are ready, guys, I think really this is simplification. It is very demanding, no doubt about it. Okay, keep that in mind. In this formula you put it and then work it out. Basic maths, you have to do it. But once you do it yourself, I don't think so, you will be left behind in working out the question to your satisfaction. Okay, so quickly take it down. So this is by definition ab initio, first principle. In all three means the same thing. That means using this formula and getting me the derivative of the function. That's what it is given over here. Okay, so take it down. 3 minutes, yes, 3 minutes. And if you miss out something, don't worry, in the end you will get a time and opportunity to copy the remaining part. So 3 minutes from here starts now. Quickly. Okay, go ahead now, next one. Don't worry, in the end I will share these notes, but you write down when I am giving you time, okay? Whatever is missing, we will see later on. Okay, next question now. So remember one thing, I am giving a mix of limits and differentiation so that, you know, in the paper also when you move from one topic to other, there is no, you know, mess up of your understanding on the particular method of working with the questions. So here we go, limit of x raised to 15. So remember one thing in limit sum, whenever you have a big power, okay, so these two formats I want you to always remember. You remember this formula, limit of x raised to n minus a raised to n upon x minus a as x approaches a is nothing but na n minus 1, or one more formula, x raised to m minus a raised to m upon x raised to n minus a raised to n as x approaches a is na n minus 1. Sorry, this is m upon n a raised to m minus n. I beg your pardon there. Yes. It is m upon n a raised to m minus n. So this form, you remember this. So see, any limit 7 power is that try to find out whether it belongs to any one of the format. So here in both side power is there. So this I believe, I can write this as limit of x raised to 15 minus 1 raised to 15 upon x raised to 10 minus 1 raised to 10 as x approaches 1. But make a note, it is x tends to a. If this is x tends to 0, you cannot apply this format. It is a is a non-zero number. It can be negative or positive, whatever. Now coming to the point, if you see, can anybody tell me this sum belongs to which type, first or second? First or second type, come on. Second, yes, absolutely right. Now look at this, what is the pattern I will tell you. The powers are same, denominator powers are same, denominator powers, but this a should be also same with a minus sign, then only I can apply the formula. So after this you write this form to tell the teacher that this sum belongs to this format, and then m is 15, n is 10. So formula is nothing but 15 upon 10, 1 raised to 15 minus 10, a raised to. So a is replaced by 1 here. So answer is 15 upon 10, because 1 raised to any number will be 1. So I think 3 upon 2. So this is the answer for this particular question. Got the point? 2 minutes. Copy down this form also and this sum also. So hurry up fast. 2 minutes I give you. Quickly do it. Short sum, wherever short sums are there, we can work faster.
Yes, sir.
Okay, great. Find the dy by dx by first principle. So immediately when I say first principle, this comes to my mind. Formula for finding the derivative by first principle method. So let us do the same thing, but unlike in the previous case it was an algebraic function, now it's a trigonometric. Whatever it is, I have to follow it, that's it, that procedure. So first thing, I want to find dy by dx by the first principle method. So I will write the formula quickly for you. Dy by dx is nothing but what is given to you, limit of f of x plus h minus fx divided by h as h approaches 0. So may have attention here, this part of the derivative finding the method procedure, the formula for first principle is important. Now let us quickly go ahead and start understanding what I need to find dy by dx. F of x is given to you, so I have to find f of x plus h. So I will just write on f of x for your information. So f of x is nothing but root of cos x, and f of x plus h, because that is the next thing what you require. So remember, f of x is root of cos x. So f of x plus h. So x is replaced by x plus h. So in the sum also, x will be replaced by x plus h. So this will become root of cos of x plus h. Take these two values and put in the formula. So let us see. Dy by dx will be equal to limit of h approaches 0. What is f of x plus h? It is nothing but square root of cos of x plus h minus, what is f of x? Root of cos x upon h as h approaches 0. I really don't have anything to work on that. I want you to just pay attention now. If I want to use the formula and find derivative of root of cos x, will become 1 upon 2 root cos x, and by chain rule it is minus sin x. So answer is minus sin x upon 2 root cos x. But I don't want this method, I want the first principle method. That's why I am going with this formula. Okay. So I am in a situation here. If you see a situation here, I am in the limit part of the sum. Okay. How I do it? So if you remember, I cannot take the limit because h is tending to 0. That means I have to simplify this. So I did substitution, which cannot work. factorization cannot work, but when roots are there, you always follow and simplify this by using the rationalization method, right? So what is rationalization? Rationalize the numerator because it has a root sign. So let us pick it up quickly. So dy by dx, I am rationalizing the numerator, limit of h approaches 0, root of cos of x plus h minus root of cos x upon h multiply by. So numerator and denominator by the rationalizing factor of the root. So it will be root of cos of x plus h plus root of cos x upon same thing root of cos of x plus h plus root of cos x. So immediately let me see what happens now. Dy by dx, if you want you can write it here, dy by dx will be is equal to limit of h approaches 0. Now try to what happens, a minus b, a plus b. I repeat, a minus b, a plus b is a square minus b square. So cos of x plus h minus cos x upon, okay, upon this will become h into, this will be as it is, cos of x plus h plus root of cos x. Okay, I think I am done with this case. Now after I rationalize this, I came to this situation. Now look at this. Who can tell me what you can do next? I cannot take the limit because h is tending to 0 into anything will become 0. So I cannot take the limit now. So I have to see something whether I can simplify something in the numerator. Can you think of something what you can do in the numerator? Think properly.
The formula cos a plus b.
Cos, yes, that also you can do. Cos a cos b. Would you like to do that? Okay, she says cos a plus b, I can apply the formula, in fact that is more simpler to do it. Otherwise I can say cos c minus cos d. Cos c minus cos d is 2 sin sine. Okay, but if you don't remember the formula, you can apply cos of a plus b. Let me see whether we can get that by what she said. Diya, I think so. Limit of h approaches 0, right? Cos a plus b is cos a cos b, cos a cos b minus sin a sin b. This as it is. I really have nothing to say in the denominator, will be left out as it is. I really don't know what to do. Okay, let me see. So h, I have a doubt whether we can work out. Anyway, let us see. Cos of x plus h my plus root of cos x. Remember this h has to cancel. Okay, remember this. Okay. Now, what you think? Remember h is approaching 0 here. Okay, I can do that. Now you know there are a look is, I think it would be difficult for us to work out, you know, with this method, because this h belongs to all. Okay, and I feel it is will be difficult because here even though h is 0, if I cannot take the limit here, cos h will be 0, 0 upon h is 0 number, so I can't take the limit. So I think this application of this formula would be a little bit not preferred. Rather than that, I can do something else. I can apply cos c minus cos d. Anybody can tell me what is the formula for cos c minus cos d? So I will not follow this, because I am not able to simplify further. Can you tell me what is cos c minus cos d? Let me apply the formula for numerator cos c minus cos d. What is cos c minus cos d formula?
Minus 2 sin.
1 minute. Cos c minus cos d is 2 sin c plus d by 2, put a minus sign, sin c minus d by 2. Okay. So this is the formula for finding cos c minus cos d. If you don't remember it, take yourself back a little bit and let us see. So what is my C? This is my C and this is my D. C is x plus h and D. Let us apply that formula and see what happens here. So dy by dx is equal to limit of h approaches 0. Okay, please don't forget this method. Cos C minus cos D is minus 2 sine C plus D by 2. So x plus h plus x by 2, simply you have to get it. Then sine C minus D, so x plus h minus x upon 2. Okay, now I wrote cos C minus cos D, the denominator will map up accordingly now. So this you can write h here, this is square root of cos of x plus h plus square root of cos x, okay, as h approaches 0. Now what happens, let me simplify whatever best is possible, this will get cancelled. Now I am writing this again so that you don't dy by dx limit of h approaches 0. Now this I can write minus of 2 sine 2x plus h upon 2. This is sine h by 2. Now make a note of it, what I am showing you. Okay, now look, this is one term, this complete is the second term. So the second term I write first. Why I will tell you, cos of x plus h plus root of cos x. Put a bracket so that you don't mess up. This h I am bringing below this because there is a multiplication sign, that's the reason. So everybody knows limit of sine theta upon theta. So what I can do is quickly I can divide by 2 and I can multiply by 2. Why I did that? I took this h below sine because I can use the formula limit of sine theta upon theta as theta approaches 0 is 1. So I am converting this. So if you see this carefully here, what will happen now? Limit of sine theta upon theta will become 1. So that sine goes off and this 2. So what better I can do is now I can cancel this 2, I can cancel this 2 also. Now let me write down what is left out. Okay, so remember it is just basic maths I am doing, I am not doing something different. So dy by dx is equal to limit of h approaches 0 minus sine. Now see, this will remain as it is. Sine of 2x plus h upon 2, great. This will be 1, there is nothing here, the denominator will be left out, root of cos of x plus h plus root of cos x. Now if you see carefully, if you take the limit now, this is the denominator, if you put h as 0, the denominator doesn't become 0. So I can take the limit, right? So taking limits, what is taking limits? Putting h as 0. So what happens now, quickly tell me. So dy by dx is equal to, just say I am taking the limits, this will become 2x plus 0. 2x plus 0 is 2x. So 2x upon 2 is x. So this is nothing but minus sine x upon, because 2 gets cancelled. Now h is 0, not x. H is 0, so x plus 0 is x. So cos root of cos x plus root of cos x. Root of cos x plus root of cos x is what? 2 root cos x. 2 root cos x. So this is my final answer for finding derivative. Now if you think function is given to you, what is derivative of root? Root of anything is 1 upon 2 root that thing. And by chain rule, inside function is cos x, so this will become minus sin x. So answer is minus sin x upon 2 root cos x. Minus sin x upon 2 root cos x. This is the formula method. This is the first principle. Class 11 talks about first principle method with its full force. Keep that in mind. Okay, but I hope you got this point clear. We will do sums on this also when we are doing directly by formula method also. Okay, right now that's not a cup of tea. So I hope you got this point. Good question, focusing on first principle method. Hint is there. Take it down. 3 minutes. Note it down. Quick. Let me have a quick look at that. One more question we will do. We'll give back very short time. This notes will be passed on to you all, so just relax, okay? Right now, again there is a limit question now, evaluation of limits, no issue. Let me see how I can take it up further. X raised to 4 minus 81. First of all, let me always tell you that whenever any limit sum is there, try to take the limit and find out whether you get 0 in the denominator. If you are getting it, that means the indeterminate form. You have to fall back on the different techniques like factorization, rationalization and all that stuff. So let us see what happens. So here 3 square is 9. So I'll just write this out so that 3 square is 9. So 2 9s are 18 minus 15 minus 3. Oh great, this becomes 0. That means this becomes 0 upon 0 form. If I take x as 3, this will become 0, this will become 0. Denominator 0 aa gaya, matlab it's an indeterminate form. That means I have to fall back on what? On the technique. So what is the technique? The first technique is factorization. Yes, algebraic function, I can talk about factorization. I taught you about synthetic division. Factorize this part quickly. So I am just doing the factorization of the numerator now. Pay attention now. So this I am talking about x raised to 4 minus 81. So write the coefficient in descending orders of the powers. 1, 4 ke baad cube, 0, nahi hai na. Square, there is no square, 0. X, there is no, and write this minus 81 quickly. Okay, and this is x tends to 3. So 3. Take the first one. 3 1s are 3. 3 3s are 9. 9. 0 plus 9 is 9, 3 9s are 27, 0 plus 27, 3 into 27 is 81. I am working. Whenever you get 0 here, remember this is the remainder there and this is the quotient. That means your working is okay. Similarly, let us look at this factorization also. 2, minus 5 and minus 3. I am writing the coefficient. 3, 2, 3 2s are 6, 6 minus 5 is 1, 3 1s are 3. Yes, this is 0. That means my working is done. Now I can factorize this quickly. How I will tell you? Let me tell you now, share with you. So limit of, okay, what I do, this is the quotient and this is the divisor. So quotient into divisor plus remainder, you know the working. So as this starts with 4, so this quotient will start with cube. So this will become 1x cube. After cube comes square, 3x square, because these are coefficients. Plus 9x plus 27 into, remember quotient into divisor. I had taken 3, so divisor is ulta, x minus 3. If you multiply this 2, you are going to get x raised to 4 minus 81. Similarly, let us talk about the denominator. Denominator factorization I did here. This is the quotient. So what is the quotient? It starts with square, so this quotient will start with 1 degree less. So 2x plus 1. Right, 2x plus 1, and this is x minus 3 as x approaches 3. So my job is over once you factorize it. See, if your synthetic division you are not getting it, do the long division method. Divide this by x minus 3, divide this by x minus 3, you will get the same answer. So once you get it, I can cancel it. Now you look, the denominator will not be 0. So let us write it out quickly. So this will become limit of x cube plus 3x square plus 9x plus 27 divided by 2x plus 1 as x approaches 3. So 2 3s are 6, 6 plus 1 will become 7. So that means it's not becoming 0. So I can quickly say, taking limits, take the limits now quickly. So this will become 3 cube plus 3 into 3 square plus 9 into 3 plus 27 divided by 2 into 3 plus 1. That's the final answer. Solve it now. 27, 27, 27, 27. 4 7s are 28. 4 2s are 8. 108 upon 7. So this is my. So the limit of this answer is 108 upon 7. So it's a fraction decimal. Okay, that is. I hope you don't have any reservation that when you get a fraction that is wrong. It's not that way. Okay, keep always that in mind. Every value has its own significance and its importance. Okay. Now I hope you got this point clear, children. So remember, whenever algebraic function happens, yes.
So can you just factorize x raised to 4 minus 81 by long division, because I got different.
Okay. See, let us see. I will show you. Okay. I am going ahead now. X raised to 4 minus 81. Now remember, x is tending to 3, write x minus 3. Because x is equal to 3 you are taking, na? So I take x minus 3, ulta, okay, divisor. So now this will be x cube. So this will be x4 minus 3x cube minus plus. So remember, this is x cube, this is 81. So they are unlike terms. So I will write this 3x cube minus 81. Put the plus sign here. X into what will give you 3x cube? 3x square. Now 3x square into x is 3x cube, plus into minus will become minus, 3x square into this will become minus 9x square. Out, this will be minus, this will be plus. Again they are unlike terms, so this will be 9x square minus 81. So x and this plus again 9x square. So x into 9x will become 9x square minus 27x. Still I can do, this is minus, this is plus. This cancels here, this cancels here. So 81, it will not, unlike terms, again it is 27x minus 81. So x into plus 27. Because x into 27 is 27x and 27 into 3 is minus 81. So 27x minus 81, this will be minus, this will be plus, cancel, remainder is 0. Now look at the quotient here, x cube plus 3x square plus 9x plus 27. X cube plus 3x square plus 9x plus 27. Quotient and x minus 3. So quotient into divisor plus remainder is 0. That's what I wrote over here. Okay. Okay, I think that's what good question you asked, because some students don't know the cyclic division. So you can do the long division also, there is no harm. But this way you can quickly do it instead of doing the Ramayana and Mahabharata. Whatever suits you, you can really work on that. Okay. So I hope you got this point clear. There are some quick questions are there, but I am short of time. But definition is there. So what I can do is f dash x means find dy by dx, right? So you know f of x plus h I have to get is 1 upon x plus h, and then you will apply the formula to this. Dy by dx is limit of f of x plus h minus fx divided by h as h approaches 0. So what I suggest and request you is, and I am a little bit short of time now, you can complete these sums. Okay. Now here there is no need first principle. Here you have to do u by v rule. So fx is u upon v. What is f dash x? Here they are not set by first principle. So v square v derivative of u minus u derivative of v. So follow this rule and find the derivative of it. So there are sums, quick sums are there. So I will share the sums as well as the notes quickly with you all. But I hope you know the point. What I want to share with you is, whatever we have done, remember we are trying to cover up as much as possible at our end. Okay, but definitely a lot of time is there. We will also work tremendously and very aggressively on the revision front now. Okay, and I hope you got this point clear. Okay, how to go about it, and you got an idea of what the limits and derivatives are in store for you, right? So thank you very much for being with me.